Hello everyone, and thank you for coming to another one of StatSlice's Analytics for Business webinars. Today is on Amazon Redshift and Tableau, and I was waiting a couple of minutes just to let any latecomers join in, but we're going to get this started. So just a quick note about StatSlice. We are a Dallas-based analytics business intelligence consulting company. We focus on delivering cutting-edge analytics, and we partner with leading BI vendors to do implementations, training, support, you name it. We put together whatever your BI needs are. The webinar overview, this is part of our Big SQL Analytics group, analytics series. You can find more on our website on Big SQL Analytics by going to statslice.com. And today we will be focusing on using Tableau to analyze big data provided by Redshift. So first of all, why Tableau and Redshift? Tableau, it is a drag-and-drop SQL generation tool to generate great visualizations. It's easy to use and easy to learn. And Redshift is a high-volume, real-time SQL engine. It allows us to use large volumes of data and get real-time SQL results based on that. Combine them, we can gain a lot of insight into large data for a business, and it has a very low BI and DBA overhead to run. Talk about Redshift scalability here. Traditionally, for an in-house BI platform, as we scale out the amount of data, performance doesn't necessarily increase or keep at pace as we scale to hundreds of millions of records, even into billions of records. Performance drops. In Redshift, the reason we like Redshift is as we scale up, we can simply scale up that massively parallel platform and see that same performance that we saw at 100 million records at 1 billion records. The data model we're looking at today is a 2012 sales data by day. We generated about 50 stores, 100 products with subcategories, and we only generate about 300 million product sales. So the base table we're hitting is about 300 million rows. It's all generated data, 3 tables, and real simple joins between them. Just as a note, we did no indexing or anything else in terms of Redshift. All we did was push up the tables, just dump the raw tables off of our local database and push them up. So talk about performance a little bit here. This entire run for the webinar is done with 4 large nodes. We use a smaller data set in the webinar, only 300 million, to keep us at about 12-second queries. But this is scalable up to 16 extra large nodes. So we go up to 16 instead of 4. You can go up to 1.2 billion and see the exact same performance. Or going to extra large nodes, you can actually go even larger than that. Performance metrics, I ran a test on this at 1.2 billion rows on 8 large nodes and saw about 25-second queries, which is what I was talking about earlier, how we have a linear scalability. I quadrupled the data set. We've doubled the number of nodes that we hit, and our refreshes are about 25 seconds, only about double the time that it was before. If you have any questions on performance or want to look into what you can do with Redshift, take a look at our previous webinar. We did a Big SQL Analytics. Bernard actually ran that one, talking about just straight performance, when we're getting into multi-billion record tables, 3 billion records, etc. Let's go into the Tableau demo. A couple of notes on the Tableau demo. Some assumptions here is that, one, you have set up a Redshift cluster. That's outside the scope to walk how to set these up. And that you have Tableau Desktop installed. So first thing I'm going to do, we did have a question here, what's the difference between large and extra large nodes? All it is the amount of storage that you can use on a Redshift cluster, as well as the amount of compute nodes that you're given per run. If you want, you can go onto Amazon's website to get the exact specifics. I don't have them in front of me, but it's about double. It's, I believe, 4 times the amount of storage and about double the compute nodes that you have access to. So let's take a look at Redshift just to give you an idea as to what we need to look at. Right now I'm in Amazon's management. We're taking a look at their clusters, and we're going to take a look at this sub-POC large cluster. As you can see, it's up and running. It's healthy. A couple of things that you need to pay attention to when you set up a cluster. Once it's up and running, it'll give you an endpoint. That's what Tableau needs. Thing to note is that the port is different. The default port for clusters is different than what Tableau will automatically select. You need to know your database name. You need to know your master username, and then when you set this up, it will ask you to set up a master password as well. That's all you need to connect. Redshift does give you some nice information. I'll bring up another section here where we can look at queries. You can actually break down and see how which queries ran, how long they took, etc. In real time as Tableau is running them. Next thing you're going to need is Tableau drivers. So Amazon Redshift has its own driver. Right now we're going to take a look at tablausoftware.com/support/drivers. They give you a link for Amazon Redshift. It's just an ODBC connection. You click this and it'll download. I already have this installed, but if you did need to install this, just download it, run it. So click the PSQL ODBC connector, and it'll run you through an install process. Now, since I already have this installed, I'm not going to remove or change this, but just next install. You don't have to do any configuration. You just have to install the actual driver so Tableau can talk to it. So let's go into Tableau. So in Tableau now, we've got just a blank workbook here. I'm going to connect to data, and we're going to go to Amazon Redshift. As you can see, it's asking for a server name, database server, username, password. So let's copy and paste that off of here. I'm just going to copy it off the screen. When you connect, right now Redshift is going to show you all the other temp catalogs. Any tables you create in Redshift will show up in the public schema. So when you first connect, it'll ask you what schema. Select public, and you'll see the different tables. We're just going to do 3 tables: sale, store, and product. So I'm going to start with sale here. We're going to multiple tables. I'm going to add product. We don't need the product key. All I care about is the category, sales price. We'll check the join. Tableau automatically saw that, hey, there's a product key in my sales table, there's a product key in the product table, and creates the join for us. We'll add one more table, and we'll grab store. Again, it selected, created the keys. And I'm just going to remove some of the keys from here so they don't show up in our sales table. Nope. Let's rename this to Redshift Data and connect. So once you connect, Tableau is going to ask you to, if you want to connect live, import all data or import some data. If you have a lot of data like this 300 million row table, I would not suggest importing all the data and just connect live. So we can look at that. And delete this quick. As you can see, here's the connection that we used, Redshift data right here. So I'm going to pull up number of records to show you that we're hitting about 300 million records. Now, keep in mind, this is real time, so this is hitting the Amazon cluster. It just hit the Amazon cluster, did a select count star off of it. In fact, let's go a little farther, and I will show you the queries themselves. Let's refresh this. You can see this query right here is what just ran. Tableau ran this to pull in its count. And actually, there's lots and lots of statistics, information on how your cluster is performing, etc., based on this. By the way, guys, if you have any questions, you can use the question pane on GoToWebinar, or you can use the chat if you have questions that come up. You're more than welcome to. I've got Danny Tipton on the line here watching questions and asking me accordingly as they come up. Anyways, let's go back in. So now I've got Tableau hooked into Redshift. Let's go bring up. I've pre-created a dashboard here that we're going to take the point of view of an analyst and take a look. Right now, all I did was I said I'm going to grab what sales we did per state. There's multiple stores in each state, what categories those products were in sales, and then a graph of all the subcategories for those. So this particular analyst wanted to know what sales they did, and we're just going to run through and build this. But first things first, let's build this map. Nice, quick, and easy. Pull off some records, and bring in state. Now, as Tableau is running right now against Redshift, we're going to see refreshes. It's about 10 to 12 seconds per refresh as we pull in each piece of data. Tableau is actually running new queries. If you want to speed it up and we're building a visualization, we can always go up here and turn off auto updates. Then we can make changes to the visualization and then refresh it accordingly. I'm going to leave them on though for now. Pull in sales price to color. Now we've graphed out the sales price at each location. When we go a little farther than that, we're going to put it also on label. And let's pull the state on the label as well. Total sales dollars we've done for each one of these. We'll clean this up just a little bit by going to sales, default properties, number format. Let's make it a currency, no decimal places, and put it in the millions. And just so we match our other colors, let's edit the colors real quick. Let's do red, blue, diverging, reverse it so we get a nice little heat map. So we can see that Texas, we do a lot more sales than we do in California in this. Let's rename this sheet to map. Next, we're going to build the category list. So we want to know the number of items sold, the total sales, and each category that's in here. Let's actually bring this in and create a hierarchy. And let's pull category here. Again, we're refreshing the query and just pulling the data straight from Redshift. You know, we're hitting that 300 million row table. A couple of seconds it runs. Pull number of records out, so how many sales we actually did. And let's pull sales price as well. And again, in Tableau is just refreshing these queries every time. If I go back into the dashboard, we would see what these, if I go back into the Amazon dashboard, we would see these queries actually running. Just to make it look a little cleaner, let's do color on here. Put the colors, do area red. And we'll sort by sales price, whatever we sold the most of. So edit the alias, call it sales, and call this other one count. And back from our original dashboard, you can see that I've built almost the exact same look and feel right here, this category list. Last but not least, we're going to build a subcategory by date at the bottom. So we're going to graph out subcategory sales by date. Again, we're only looking at 2012 data, but we'll pull it in. Let's rename this. So we'll pull number of records into rows here. Let's split out on color to be by subcategory. Now this is going to give us a lot because we have all the categories in there. Well, let's pull out sale date by columns. By default, Tableau is going to pick the highest granularity year on sales date. We're going to break this down to either days, quarters, etc., and show you how we can quickly flip through it. Well, let's switch this to quarter first and see the data. Not sure why it's taking a little longer than usual. We had a question here asking about configuration of colors, etc. So again, when I talked about pausing the refreshes, if you pause the refreshes, change all the configuration you want, so what colors, etc., and then do a single refresh, this should come up. I'm going to take a look at my Tableau instance. Oh, it came up. Not sure why it took so long for there, but every other time it's been about 10 to 12 seconds. As you can see, we've now broken up sales by each one of the subcategories by quarter. I want to get a little more granularity on this. I'm actually going to switch this all the way down to day. That's going to run a new query here, so you give it a minute. And this should break up all of the sales we've done per day. Yeah, I'm not sure why it took so long for that first one, but now it's nice, quick and simple. As you can see, we've got all the sales we've done per day from January 1st to January 1st. Let's rename this to subcategory by date. And now let's throw this all into a quick little dashboard. Let's bring our map out. Let's bring our category list out. Change it to full screen. And let's pull our subcategory by date into the bottom here. So far, so good. We have, I'll make this look a little nicer. We have some dashboard popped up, but no interactivity whatsoever. Now, if I click on California, I don't see any data. change. If I click on NN here, I don't see any data change. We'd like to add some interactivity, so when I select California, we'll only see categories from California and only subcategories from California. Let's do that first. Just choose Use As Filter. So now when I select California, it's going to requery the database just for California. Now we're only looking at California data. Yes, this is a little ugly, but we'll clean it up here in a second. The next thing I'm going to do is I'm also going to use this as a filter. Now if I select NN, that is going to update both the map and the subcategory. I'm going to actually fix that because I only want NN, I only want the categories to modify the subcategory. So this is our map. As you can see, source is map. I want it to affect category list and subcategory by date. And when it's not selected, we want to show all values. Okay. And let's edit this one. As you can see, it comes from category list. I don't want it to affect the category list or the map, but I want it to affect just subcategory by date. And when you have nothing selected, I want it to exclude all values so we don't see all of that number. So now, if I select California again, we'll update there, and I select NN, it's only going to give me category NN for California. If I break this up, I get rid of NN. Now I don't have any subcategories because I don't have a category selected. But I can go through and take a look at Brion or Brunsforge and still see all the subcategories for them. So that's the primary setup for the demo. One last thing I'm going to show you guys is now that we're hitting this 300 million record table, we can very quickly extract this data and aggregate it up so that we have a very small dashboard to show. So we have a very small dashboard that we can either post on Tableau server or actually email out to anybody that has this data, and they have the data extracted. They don't have to have a live connection to the database itself. Let's run the extract. While we are running the extract, I'm going to bring up the queries so you guys can see what's going on right now. As you can see, it's executing the query. It takes about a minute and a half to run this. You can see right now it's running this query. You can see all the other run times for all the queries that we ran previously. I'm going to hit this one that's actually running right now. And since this is running, I don't believe it can get performance and details on this at the moment until the query finishes. Since it's currently running, you can get some of the hash plan and what's going on. Then you can see some information about what's going on in the background as these queries are run. See what this one took. This was the quarter query that took over a minute to run. Looks like it took a while because it's doing a cast. I'll refresh this. Been running for a minute and 21 seconds to extract this data, as you can see. Pull this on the side. Wonder if the Redshift cluster is just getting hit a lot more today. Well, while we let that extract, I'm going to bring up the PowerPoint again and talk about some of the expected use cases we see with Tableau and with this. We have the ability to basically, in real time, do some large data set analysis. Anytime you can see that we're getting 10 to 12 seconds at 300 million rows where I am dragging and dropping, and this is a live connection. Once this extract finishes, we have refreshable dashboards based off of these large data sets. Tableau is going to aggregate. In fact, I think that's what I did. Hang on one second. Tableau is going to aggregate this data into what is visible on your dashboard so that you get a much smaller data set without any BI use or anything else. It's just what you have selected as dimensions. Tableau is going to automatically aggregate and pick up all of this data. That would allow us to take this dashboard, then push this up into a Tableau server, have it refresh once a day, extract and aggregate all this data so that any user can quickly look at a real-time dashboard. Just a quick visualization as to how this would work in your company. You have an on-site data warehouse. We're expecting you to have an on-site data warehouse. You would write some ETL to use large flat files to push them up into S3. Redshift loads the fastest, pushing directly from or pulling directly from S3, just flat files that we pull up. From Redshift, then you can use what I just did today with real-time analytics and a real-time connection using just being able to build these visualizations. Or you can run a Tableau server, upload one of the dashboards like this, and have it just extract on a timetable and pull that data from Redshift then to a dashboard user. Since I have another dashboard up right now that has this data extracted, I'll end up showing this to you just to show you how quick it performs now, because this is the exact same data. If I go to map, you can see this is a extracted data set, the exact same set. This is the exact same dashboard that we did, but now we're only looking at extracted data. So we're only looking at probably about 100,000 rows that Tableau is actually looking through. And you can see updates are almost instantaneous across the board. Let's save this as workbooks. Well, here, I've saved this as, just want to show you guys the size of this dashboard. Let me make sure this is saved as a packaged workbook. There we go. So once I choose a packaged workbook, Tableau is actually saving this. Tableau is actually saving this with the data stored. The total file size is about 3 megs, 3.3 megs. So easily emailable if somebody has Tableau Viewer and can use this dashboard without being connected to Redshift. Okay, well, let's get into some architecture notes. Quick note, Redshift is still in beta according to Amazon, so that's a caveat to everybody. But it is easily maintainable. You know, we can click a button, we can double the number of nodes. Let me bring that up and show you. Now, I can go back to configuration here, and we can choose modify. I'm sorry, not modify. I can choose resize. Right now we're using extra large instead of 8x large. It's a multi-node configuration. I can go to 16 nodes on this very quickly and hit resize. Takes some time to do. That's why I'm not doing it in the demo. Because it copies takes a snapshot, it copies, and then reloads this with a larger node set. But very quickly, you can within an hour or so, you can ramp this up in terms of performance. It's on demand. You can shut it down when it's not used. So in your ETL process, you end up generating this data, pushing it up into S3, and then turning on Redshift to load your data, run your extracts, and then shut it down when it's not used. Total cost per terabyte of storage is about $1,000 per year, depending on how many nodes and how long you keep them up and running. If you were to leave a single cluster node up all year, it comes to about $1,000. And it's encryptable with minimal impact to performance. You can encrypt your data on the server side so nobody else has access to it. And if you take a look at our previous webinar, we did some tests on the encryption queries versus the regular queries and how quickly they came back, and there was minimal difference in performance. A couple of links for anybody who needs them. Tableau software. If you don't have Tableau, you need to go to the Tableau drivers, Tableau software /support/drivers. If you Google support/drivers, or if you Google Tableau drivers, it'll take you, first result will take you right to it. And if you have questions on Redshift, just go to amazon.com/Redshift. Thank you. Please send any questions you have to jvogel@statslice.com. I'm going to leave this open for any other questions you guys have. Feel free to ask them. I can run more queries. I can do some other visualizations. I can show you some more information on Redshift itself. Just let me know what you need. I'm going to leave this open for another 10-15 minutes. Thanks again for attending. So somebody asked when Redshift is going to be out of beta. I will have to get back to you on that. I need to do some research for that. Let's see. For anybody who's still here, I'm running the extract right now to pull some of this data and see what I get. And now we've created an extract. Only took a couple of minutes. I'm not sure why it took so long earlier. And we're running off of extracted data instead of running live queries. Let's drop this to week instead. 1 month. All right, since I don't see any other questions coming in, I think I'm going to shut this down. Again, if anybody is interested, you're more than welcome to shoot me an email at jvogel@statslice.com. I'd be more than willing to show you some more information on how Tableau works and how Redshift works. And look forward to seeing you guys in our next webinar.